Okay. Um, this is kind of like a gift session. Uh, we've been talking about this from different perspectives, and we're going to and try to address all of the aspects of software modeling. Um, Modeling as يعني, some definition is that we use like data bags to put primitives and values in, like a database record or a form submission or whatever. This is like one way to describe it, but the way we did uh, objects, structs, and all of these ways of modeling data is not just to bag some data. It was for a higher level reason. So the idea is, yani, I'm not talking about like C structs. Yani, this is completely different. If you're going to use C or C++ or whatever, this is a different scope because you're building for the system. It has completely different constraints. It's you have different goals, but in a different world where higher level languages that have been long created, we have all of these methods to create and describe uh, the problem and the statement. And this is what I'm talking about by modeling. We have ways, and I'm not even talking yet about like a type system. I'm talking about just the way we can group data to create a higher order data or higher form. Um, so let's take this as an example. Uh, the thing is that we created all of this just to have a way to better describe the world. It's just like what we do with languages. We have vocab, and you can have three people and give them the same issue, and they will be different in how they represent it. And you can understand from one, but not from the other. You can have issues understanding at all, and it all depends on their understanding of the issue, the way they describe it, their tone, their language, their vocabulary, all of this. It's exactly the same in programming languages, and the more you understand the issue and the more you use the vocab and combine vocab to create higher order vocab to represent your issue, the more you're going to have um, like an easier time to implement it and also describe it for others, which is the primary goal of writing code and not just writing machine code that only runs. Um, if you're like familiar with some languages like German, or like I'm talking like human languages, and you guys, okay, you guys also like are fans of anime, so you know kanji and all of this stuff. It's basically a combination of words. Uh, Not this is an oversimplification, but it's still you learn a syllable like word called Mara, I think, something like this, and then you combine them to create a higher order word. Same with German and other languages, it's the same here. As you can see in this in this diagram, it's not really a diagram, but it's basically if we assume that our primitives are just like the primitives of the language, like the very simplest form of any type of data, like an integer or a string or whatever, uh, being combined, this they create this higher order type or higher order value. Um, so we have two examples here. Like I can just say in my package of data, let's turn off this because we are using the generator. We're not really, we don't have, we have two ways to describe an age, an integer age. We assume it's integer. We can use just say like let age equals 15, or let age equals an age of 15. And this age is something that you can assume that's like an object or whatever. It doesn't really matter. This is not a real language. Why would you do this? It seems redundant. It seems pointless and heavy and all of this. And it can be true. again in some circumstances, like from like if you're developing for a system. But it actually has so many benefits that you automatically gain. And even though that every single point that I'm going to mention is going to positively affect readability, it's not really the goal. Readability is not even the goal of what I'm saying. I'm talking about actual benefits that prevent errors and give you lots of advantages. So another example is this is 1 kilogram of water, and we can describe this in a different term, which is a liter. Exactly. And if you like in measures, you can say like a gallon or whatever. It's not 1 kilogram, but you can describe it in different types of like units. You have all of these ways to get rid of the complexity of 1 kilogram of water, because 1 kilogram is actually 1,000 grams, which is a million milligrams, and so on. But خلاص, you abstract all of this away, and you talk about 1 kilogram of water, which is a liter, and then you do your operations on liters instead of going all the way back to milligrams. So this is abstraction. The reason I'm stopping here is that I want to like reiterate on like a 6 month ago session that we had on abstraction, because it's the key to everything that we do. This is not going to be a session on object-oriented programming, nor functional programming, even though it is going to be lots of mentions of functional programming. It's really about anything. It's just about how we are describing the world. Because the thing is, like, you remember the teacher example that we said? The more you understand the world of your problem, the more you can put it into words, the more you can have an easier time solving it and also communicating with the others. So it's like the most important step that you can do. It's just really understand it and just express it. And we have all the tools that we need to express a problem. So we're not using them. Often we're using these primitives just everywhere. Like we use wrinkle, let age, and let email, and let password, and we will see why these can be an issue, and how we can take advantage of a real modeling system that's built for this purpose. So this is an example that I often use. This is actually a code that I wrote myself years ago. It was a part of an audio player module. So as you can see, here's a function called play. It takes a URL parameter. Just added here that it is a string because it's JavaScript. JavaScript, we don't know the actual type unless we actually use it. So what we do is basically we stop the existing player if anything is being played. We update the source that we want to play, and then we actually call the native API that plays sound on the device. Can we spot some issues here? Just it's not like big issues, not a bug. It's not. It's actually working on everything, and it can be optimal even in like minimal examples. But if we just wanted to like reach to the
Why did we say play would stop?
okay, what I'm looking for is not like functional issues. I'll tell you why. Because if something is that's already playing, you have to stop it first.
Yeah, but I'm stopping the player.
Yeah, actually, that's a side effect. Yeah, and this function is actually since this JavaScript you cannot really represent side effects. This function is not pure at all, and it's not
Is player here a global variable?
player. Yeah, it's predefined.
I think you can pass a name for the URL and it will have issues after that. There is no regex to check that this is a URL or it's not an object for specific for URL.
Yeah, that's one huge point. Other issues?
يعني it's not a big issue, but I mean, why not passing the player as well? Yeah. Here, يعني this code couldn't work in another project because in another project maybe you named it player one. So this function will not be
So player is not a global. This is like a snippet from like a file. So player is like defined right before the function because it's used across functions. but your point is 100% valid. يعني basically again this is a side effect.
No, at
No,
some
it's,
point,
it's not بس.
no, at some point, any point at least, if at some point you wanted to play multiple audios, you will have to refactor this function because it stops the player. فكان
Thank
زي
you.
ما قال ادريس يفترض تتابع البلاير من برا and then play stop the player that was fast to you and then play
I agree with the problem. I don't agree with the solution. But يعني we'll go over it. Yeah. So in the same snippet, as you mentioned, there's no validation. This URL can be anyone's name. It can be an empty string. It can be even null. There's no form of validation whatsoever. And this is going to be a huge point in the following slide. Yeah. And also, a URL is not really clear what it is. Is it an actual URL object? Like most languages provide this native API for constructing URLs, or is it a string, or can it be both? I really have to reach for a comment, which is literally what I did there, and just literally adding a comment. Yeah. And it's not future proof, which is the point that you guys mentioned. Is that URL for now, let's say, is just a string. In the very near future, it's going to be complicated to change anything that's related to this API, and this actually happened. Yeah, this is not like, yeah, and I'm not talking about like the textbook definition of object-oriented future proofing of I will switch database every 3 months. So this is why I have to make everything, literally everything can change, and this is why I don't agree with like defining like everything as in a parameter. Then the function literally loses its meaning. And then why create a function if it's just going to assemble the parameters? But it's actually very probabilistic, يعني future proofing, which we actually had. This is like an audio player module for the entire system. So it not only it plays long files or like big files or long media, it also plays like notifications, alerts, stuff like this. This is also it requires different treatment, different types and different data sources for these files. It can be cached, it can be base64, lots of intricacies. So let's take this for an example. This is like our definition. If we added a type or whatever, we would say that URL is in string. It's still the same issue. This is why I'm talking. It's not really an issue of the type system yet. Obviously, the type system will come in handy, but again, it's an issue of our own design. We can just say that audio is an audio, and audio has this definition of an object that we have added here, like a URL, but it's like an actual URL object, be it the native one or one that we could created, and a format. Let's say that we are interested in format or whatever. I'm just adding here for an example. Yeah. So what does this do? Yeah. How is this any different from just using a string? Yeah. Can we see the issue that we've just automatically prevented? Validation. And how is that? Because a caller to the function play will never be able to call it without actually providing the expected data. And you got this for free. As a creator for this API, for this library, you just ensure that no one is capable of calling your API unless they make a big mistake, which will blow up in their face. Yeah, JavaScript can just like let you pass anything if the bottle of water, like from the previous example, and if you pass it into the play function, JavaScript will still pass it, but it's like a different issue. And at least you'll get a reasonable error that you didn't have access to URL of undefined or whatever, because you did pass something that's not an object. So you automatically gain this even without using a type system. Now let's talk about how we can take advantage of this more and more. Basically bringing compile time and safety. Not just about typing, not just about readability, but also preventing major errors. So the main part and like a big inspiration for this was a blog post by Alexis King called Parse and Don't Validate. She wrote this using Haskell, talking about the difference between parsing and validation, and how it's very important and easy at the same time to fix major issues by just utilizing a type system, or not even type system, just strong arguments, let's call them this. but obviously we'll use a type system. This is Haskell after all. Yeah. She here wants يعني, the beginning she tries to give an example of a head operator in functional programming. This operator basically yeah, and let's talk about like a list first. It's again, يعني, the way functional programming handles things before there was even a type system that's good enough. Like even in dynamic languages like Lisp, which never had a type system, um, you could still create all of these things, and it's like the core of functional programming is abstraction. Even like structure and implementation is all about abstraction and how you can create types without a type system. A type system just came in to make this easier. Since there are so many constructs that are available in typical programming languages that are basically non-existent in functional programming, you have to literally describe everything. This is why functional programming is both very easy whenever you look at it from afar, like let's see this quick sort example, compare it to like one that's done in Java. And at the same time, it takes more effort because it requires everything to be processed by you. It's not like there are not many constructs that are available built in. This is why a list is literally an item and then other items in the list. And this right hand part of a list is also an item and then the remaining other parts of the list. So this is something that's actually this is like a core thing in all functional programming languages. X's is basically an array of X's, multiple X's. So an X, so X's are just an X and then a bunch of other X's, and this X is also an X and a bunch of other X's. The way you can do this, again, let's just go back decades ago. Yani we just talking about literally the most basic form of data and combining them by referencing them through a closure or whatever. So this idea is actually yani, very powerful, even though it seems simple and seems not intuitive at the beginning. But it's actually very simple. This is a true description of any list of things. It's an item and other items. This gives you, and this you can do this with functions and other stuff. But the idea is that you always have access to the first item in a list. This is now back to the head. This is an operator that gets you the very first item of any list. So this is an operator that you will see in, or a function yani, that you will see in almost every functional programming language. Ahead of a list is the first element in it. It's like saying in other languages like list of 0. So ahead, and here's the definition. This is a type. This is like the signature of the function. Head of an array of whatever. This A is like kind of like a generic, but it's called a wildcard, however, yani. And it returns a maybe A. If we're going to implement head ourselves, we're going to say that it's not always going to be the first item of the list because the list can be empty, right? So there will be times where you are unable to provide any type, any value. So ahead of just one element, or like, yeah, one or more elements, basically. I don't care about like the second part here. There's like ahead of this list is basically x0, the first element, and the rest I don't really care about. So, by the way, this is called yani. So that's not confusing. This is called a conspirator. It's like a constructor of arrays. Yeah, it basically concatenates an item to another item. And the head of an empty array is nothing. This is like a maybe. You know the maybe type. You have it in different languages. It's kind of like an either, but the left one is null. Here's it's called nothing. So you either return a just the first element or nothing, depends on the value that you have. So this is nice. It's safe. You will not have a null pointer exception, and it's nice. So actually, this is very bad. If this is a core library, and it is, this is like a core operator in almost all functional languages, Haskell included. If you had always to check for maybe, and this should resonate with you, you'll have a very difficult time working with arrays. Now imagine every time you have to call array of 0, you have to check if it's null or not. So here's the issue. Um, so she talks about this, and she actually gives an example. If you're interested in the article itself, I will give it to you. Um, she builds this function that gets directories from uh, a specific parent directory, and for every single operation that she has to check the perform on this list of directories, she has to do this check, because again in functional programming, a list is something and other things. So you just keep using head and head and head. This is how you iterate on every single element in an array. You keep using head. So now that head is a maybe, every time you have to check if you actually have a value or you have nothing. So she goes to a static solution, a static type solution, which is a type that she created and can be created in any language really. It's called a non-empty. So this is a type that has also a partial, like it's a partial type, kind of like a wildcard generic as well. A non-empty A means A as in whatever is always going to be at least A or an array of A and other stuff. So basically, again, it's like this is like a tuple in Python. A non-empty of A is A and other stuff or nothing. Okay, but at least it has at least one thing, and it's a type. Yeah, this is like the main idea, that it is a type, meaning it's resolved at compile time. Meaning, if you use non-empty on a list, which we're going to do, that means that whoever wants to use this function, he has to pass in a non-empty list. And this is how we're going to implement head. Um, by saying that head only accepts a non-empty array, that means you can always return the first element or maybe the only element. There's no maybe, because it's non-empty. You have this guarantee. So, um, so there's, yeah. So what we did right now, and I will show you the example. This is why I call it like a strong type. It's basically we strength our type of the head function, instead of just assuming it's going to be maybe in all cases, by making it weak, that it's always going to be optional. It always can be null at any certain point, which means we have to check for it in every single place that we use. But by just saying and enforcing any caller to this function that they have to use a non-empty list, خلاص, we have this guarantee, and for every single use case, they just have to provide the right type of information that we need without us worrying about it every single time. And because head is not alone, yani, it is not the only single operator that you use on a list. You use other operators. Imagine if all of them are maybes, because they are all depend on head or something similar that might not exist. She mentioned that now the code, like there's a whole example that I didn't add, which is like the get directories thing, and it was full of redundant checks of is it null, is it null, is it null, is it null, and then return early, or throw an error. Now we don't. We basically either call this function because we do know that we have a non-empty array, or we just fair early on before Aslan coding this function. So we stop checking that the list is non-empty, and its return type must change if we ever try to change this. If I'm a caller to this head function and I find myself in a situation where I might have a non-empty list, that means I will just fair early. And if I just decided that I will not return a non-empty list, I will just return a list, the compiler will actually like ask me to change my code. It will throw an error, because now I'm saying take this might be empty list and treat it as a non-empty list at a compile time level. So you get this huge benefit. This is kind of abstract, might not resonate with you. So we have another example. But just to summarize this and focus on this part, going to the next example. Parsing types preserves information about the thing or object. The reason I'm calling it a thing is that I don't want you to look at it from an object-oriented perspective. But the idea is when I did enforce an array to be non-empty, I preserved this property of this array. It's no longer just any array. It's a non-empty array. And I have this information with me every single time I use it. Every single time I pass it to another operator, it's a non-empty array. This data is always attached. But however, if I use the other one, which is a maybe, I every time I use it, I don't have this context, and every time I use it, I have to reincarnate this context. And this is like the equivalent of using this check, which we all did, like if list dot length doesn't equal zero, then okay, inside this check, we're safe. Outside of it, we have no idea if this list, even though we know here, we know for a fact that this list is not empty. Yes, we lost this because we validated, we did not parse. And parsing here is not about like not necessarily about reading a string and extracting data from it so that you don't go with the regex. And it's not just about this. As parsing is basically uh, giving more context to data that we already have, extracting this and give it more uh, information and reserving it. So be it parsing a string or actually extracting data from string or converting a weaker type that is like a whole generic list to an, a specific type of list that is a non-empty list of whatever, and so on. Now the more practical example that's also inspired by this. Alhamdulillah. By this post, which is called another post called type safe validation by Alex Ozun or something. I'm not sure any of his name. Uh, he maintains this blog called Swiftology, and he's using the same topic because he's calling it type safe validation, and he's using the same example, but now he's using an email and a password. So this is a critical thing. Alhamdulillah. معك واحد. Uh, so now we have something that we actually know the importance of. So this is a Swift snippet. Swift has this cool thing called a guard. It's kind of an explicit if else that's designed to literally like add this early on check that's very readable that you understand that this is a guard for the rest of the code. It's kind of like if and then return early, but it has a return value. You can use it as an expression. Lots of other benefits. Yeah. So basically, they are checking if the email matches this regex, and the password is more than 7 characters. If that is the case, then خلاص, we will return. Um, that we will not return from the function itself. We're just passing the guard basically. But that means we're okay to continue to the next step, which is the actual login itself. We have this auth service that calls, let's say, Firebase, this calls backend, whatever, sends the email and sends the password. And we're okay. We pass this guard check. We're good to go. We have a good email, we have a good password, and we can go. What are the issues with this one?
Still going the same issue of validation that's temporarily inside this part, and it's not parsed, so it's not safe all over the way.
How can we make it
It's
safe?
within the context. We make it safe by making sure that we pass an object that is parsed in the way that we expect.
Perfect. So we did this. Let's also give another example with another issue that Alex mentioned, which is not only do you have to repeat this check every single time, you're also prone to making it inconsistent because sometimes you'll have to rewrite it again. You can extract it to another function, but sometimes you'll also have to do it. You can do it in a test. You can have stale checks, which is you can replace this and like mistakenly by an or, and now you're done for. So it's not really, and obviously this is like a simple example for just email and password, but you can have other requirements. If you're validating the form, they will always keep changing, right?
Even if you extracted this to a function, sometimes, يعني, for example, يعني in forms, يعني you can have in the login form, like the password has to be 7, but in the update password form, it can be مثلا, for example. Does it make sense? But
Yeah.
this can happen.
Yeah.
The relation change.
So it will keep on changing every single time, and you have to match it with your test, and you have to match it in every single bit that's using it, and you'll end up with stale checks. So basically, it's only safe in the scope that we're using it in, and we will have to repeat these checks on every single time we need to access this email or password, and we can are prone to have these stale checks that are inconsistent. And now he does this very nice thing, and also he's utilizing the language, higher order language, to help him with this. He's creating this struct called email. It's a type that encapsulates internally a raw value of a string. However, you can only have a successful construction of this struct if you actually did match this email regex, or like this type criteria or whatever. So in the constructor itself in net, you have to actually match the regex of the specified email regex in this system. Otherwise, you return null, and you will not, basically you will fail initializing this object. So in any other caller, like let's say the host service dot login, instead of accepting an email, now you're accepting this email type, and it's not nullable. So you have to get it. If it's null, the compiler will yell at you, and you'll also have this exception on runtime, even if it's passed from the compiler. And if you did say that it's not nullable and passed in, but you passed in any email or your name, then it will fail at runtime, but with a very proper failure that's expected. Yeah. So with this, he goes back to the original argument that we said that parsing preserves the information and validation loses its context. He's saying it in a very like simple way that we all know that all emails are strings, but not all strings are emails. This is the information that we're losing by just adding if email matches regex. We're losing this function because we no longer know that this is an email right after it. We can use it for any other function that accepts a string. It's just a string. It's not an email. But by doing this, we're actually saying that it is an email. So yeah, why did we where did we face this very recently? We had these issues. Remember when we were working on this thing with Dart, and we basically expecting data coming from the backend, and it's a maybe, so it can be null, and we had to flood the entire like def with null checks, and also they had
Assuming returning null from backend.
yeah,
Assuming anything returning.
yeah, exactly. We're not relying on the backend. ف بس we had to assume that it's null forever. يعني it's a debt that we're carrying all over the place, even though we can just يعني just do it once and for all. If it's null, it's null. I'm no longer continue the chain. And خلاص, I will fail early. I will show an error to the user or whatever. And we also were doing this with when we were passing the VCC's payload. We just extracted this, and like we had this very quick chat about like extracting the value is not enough. You have to actually validate it and maintain this validation. Extracting this as a string and just say this is like the VCC number or like expiration date or whatever is not enough, because you're going to fail as well. Um, so this is like the whole thing about using these constructs. Again, if you remember the the very simple diagram of this cube that we had in the very first page, where just one primitive value uh, that we often use as the main building block. It's not really intended for this most of the cases. It's a building block for your building blocks. Your system needs its own language. You have a very basic set of building blocks and equipments provided by the language and standard library. So your system is its own sophisticated things that has its own problem statement and has its own world and analogies and like all of these things that fly in your system. You should create them yourself. And if you did this, your system is very understandable, it's very predictable, it's safe from lots of errors that can easily get in your way, and it's for free. يعني again, these are issues if you're using a very like now let's say an outdated language. I don't want to use this, but yeah, yeah, let's say it's like an outdated language on on an old system, or like an environment where performance is everything, or memory safety is everything. Not safety, memory optimization, everything. It's a completely different story. But now you are in a world where you're building very large scale systems that are maintained by lots of people, and you have all of these things basically going into your system. You have the tools and you have the hardware. You have you have servers. You have a very powerful machine, and you have all the tools that you need to build this world of yours. So instead of using just like basic words like 1 kilogram of water in every single thing you mention, like, or using water in your app, use your own unit of measure and make sure that's all there and it's always consistent and safe. Um, but if we did this, it's not as easy in a dynamic language, but it is still doable. It's much better in a typed language. You gain lots of benefits, and also problems automatically become much easier for you. This problem of validation has solved itself without you actually worrying about all the edge cases that you were going to do initially, because someone like that is going to like check for every single use case for this email and password, and then you will have to add all of these ifs and else's, and you will fall in this issue. So this is it. Yani, we're finished. If you have any questions or whatever.
I think an example of that, like serialization on the front end or mobile side, يعني, something like the availability for the client, the back end returns them as strings, but the moment that that response is getting to the front end or the mobile, if they used it as a string, they might face a lot of problems. But if they serialized it in like an object of date that they are going to make any operations on feature on it, it will be a lot easier and will mitigate any risks of using the primitive type of the string. يعني, does it relate with that topic?
Actually, it's very interesting that you mentioned that, because this lady, Alexis, I'm not sure yeah, we don't have anything to present. This lady actually that mentioned the non-empty type in Haskell. The original context for this is actually that she was creating a serializer and a parser for JSON. So yeah, this is definitely there. And you can lose lots of context by just saying that this is a JSON string at the end of the day, or this is a JSON object of JSON strings, and it's all, a bunch of maybes just carried in a bag, a big maybe bag. A JSON object is a maybe, and all of its keys and values are maybes as well. So, yeah.
بس I think إنه في فرق هنا between التايب بتاع GraphQL والتايب بتاع language. يعني adding this abstraction to the GraphQL layer will just add unnecessary complexity. لأنه مثلا يعني the same مثلا date type اللي هي بتكلم عنه زياد. The date type in the programming language, يعني the benefit of creating a date type هو validation. يعني if I pass an undate string, it will fail. So I will not even have a date. So when I'm working with the date type language, I'm 100% sure this is the date type. This is the date type. Problem check. ثانيا انا عندي functions that I can apply on dates, adding dates, subtracting dates. يعني date math is already handled for me. I don't have to worry about it. يعني عندك كمية بتاعت helper methods that يعني are associated with certain types.
I guess you're not really getting the point.
مشكلتي مع الاريا هناك انه في GraphQL if we try to return a date type يعني you can't have that sophisticated level of.
This is not the point. Yes, you do have these. Yeah, this is not even related to GraphQL at this point. Yeah, in any programming language, you have utils that work on dates and date times and date utils and all of this. However, you have your own specific criteria of a date. Like, let's say you're creating like something that's related to check-in or check-out or whatever. This is like a criteria. Now you have this augmented or strong date type It's a custom type that's specific to your own world. That's also a date, but plus other stuff, which is like for in this example, like validation stuff. Here you pass the date and you have it, and you attach the context, the business logic context with it as well. It's not about like not using the type, using another different type. No, it's just about augmenting it and preserving its validation state or any other state really. It's one and the other. And again, if your system is like built on top of all of these, it might seem redundant. This is why I started with like let age equals age. Age at the end of the day is just a wrapper of like 15, so it's still the same thing. You might look at it as like I've created this memory overhead for nothing. Obviously, there's like yeah, there's a situation where you have to draw a line, but again, you gain lots of benefits from doing this if it's this age has to fit a specific criteria. And also it's not really that it's not at all an overhead, because actually most languages now do these unboxing things where they just unwrap the value inside this wrapper object and just use it at compile time. There are languages that use this even explicitly by just saying that this is like a value class. Like this is a keyword that's in Scala and Kotlin, I think. We're just saying this is a value class of an integer, and I will call it age. So it's an object that's called age, and you cannot pass an integer instead of an age. However, on compile time, it gets unwrapped, and the value itself is used, and every single usage of it is now an integer. Because at runtime, class you're already safe, because you already passed the compile check. So you get the benefit of a type system by being this explicit about it's not just an integer, it's an integer age, and at runtime you don't get the memory over it. And many languages do this automatically also without having a specific type of class. Yeah.
Maybe adding to this, it could be مثلا legal age. The constructor you check that it's 16 and above.
Yeah, exactly. And it's always preserving its context. This is a legal age. This is not just any number. This is not any age, and it's compile time safe. It's the biggest benefit.
And I think the point that might got understood between me and Mustafa, that sending the date object on the response as a date, that's not the point that I raised. My point that on your backend side you are the operations that you are making on it, it will be for the type date, your own date. When you send it to the front end side, you will send it as a string. But when they receive it, they must convert it or parse it to object dates that they are going to having their operations until it get injected in the UI component. But if they made their operation on it as a string, they might face a lot of problems.
Yeah.
That's it.
Any other questions? Okay, as always, right on time, 11:45. This 1 minute is on you. Let me stop.
Yeah.
Thank you. Let me stop.
Great. Very insightful.